My name is Maggie Schmidt.
My name is Cullah.
And we are AWEN. We're thrilled and privileged to welcome you all to the first GM 2025. At AWEN, we focus on the intersection of the creator economy, governance, and emerging tech, like blockchain and AI, and anything else that will be coming out of the woodwork in the next decade. And we're also very proud to co-manage the Intersect North American Community Hub.
Yeah, like I said, we're very thrilled to be here, and thank you all for coming. With AWEN, last year, 2024, we did more than 20 different in-person events. And so we're really excited that this is the first one of 2025 here in Fort Myers, Florida. You know, we're from Wisconsin, so this is a respite. I know it's cold for some Floridians, but it's still warm for us. And just wanted to make a statement too about the community here. This is really what drives us. This is really what moves our heart, is the community here in Cardano. And we think events like this and the program that we have today really showcases the depth and the quality of what it is that the community cares about. And right now, you know, there's so many topics that are at everyone's heart, and so we're very excited to showcase that. Also wanted to just, you know, briefly mention, and we'll bring it up here in a second, but Lloyd, Duhon, and the GM Cardano crew, we can see them all here. They're all the ones that are making this all happen. And really
Hello, and thank you everybody for attending today. Thank you for coming to our little hometown here, Southwest Florida. We really appreciate having you guys come down, make a drive. We promised warm weather. It's been a little colder than we had hoped, but you know, we'll do our best to just come and enjoy the day today. We've got some really great speakers coming, so I'm really excited to be a part of this today. And you know, when Ian and Maggie approached me about doing this, I'm like, this will be fun. Like, this will actually be one of those things that we can really just get together and you know, have a good talk, have good conversations, learn some things from folks, and collaborate. Because that's, what are we really here for in Cardano? What have we as a group decided to do? We're permissionless. That means anyone can come here, whether we want them here or not, right? It doesn't, I don't get to give you permission to be here, you don't get to give me permission to be here. So we're here because we want to be here. So if we all want to be here, what are we doing? What is the mission? What is the thing that brings us together? And I've struggled with it, I've played with it, I've talked about it, I've looked through it, and what I keep coming back to is that we are here because we found an environment where what we think and what we do matters, right? So we come together because what we do matters. How do we grow that? That's the next step. So how do we take this smaller group of people that are willing to come together and willing to do this work and grow it to a larger group of people that also want to do that work? And so this year, 2025 for me, is a year of collaboration. That's my goal. My goal, personally and professionally, is to find new and better ways for us to collaborate as a community. Find ways to bring us together in new ways that we find the things that are missing, the pieces of the puzzle that aren't yet here, and bringing those together for all of us. Now, I go back to this, a few of you probably heard this, but you know, in the 90s I did a lot of work in the .com, you know, the whole boom and bust of that era. One of the big things that happened during that time frame is that we had this sort of open, everybody's welcome kind of mentality in the beginning. So you could put up something and other people would come to it and participate in it. Over time, that data became so valuable that data started getting locked behind closed doors. And that made some very, very wealthy tech billionaires. Congratulations to them. But it's also set us up to where we're subject to these algorithms, and we're subject to the whims of those people. They gatekeep the data. What do we have in Cardano? We've opened that. That ledger is open to all of us. You can't hide anything in the ledger. So because of that, we've got a collaborative environment that can't be evil. It can't hide that data from us. So much of what we can and need to do needs to focus on that. And I've heard Charles say it, I've said it, so many of us have said it. It was don't be evil with Google, and now it's can't be evil with Cardano. So can we continue to build the tools and continue to build the environments where we can't be evil? What does that work look like? And how do we, as a community, do that work? How do we show up every day and, of course, fund that work? Those of you know I'm working on the budget committee. That's one of the big things that we've got to do now, is figure out exactly how we can fund these important projects. And so that's one of the big discussions. And today we're gonna hear from Sam Leathers. Sam's going to talk a little bit about about what's going on in the ledger and what it means in Conway now that we're there. Because we're there, the Plum and Hard Fork is official. We're doing this. It's real. So what do we do now? Now that this is real, where do we go from here? So Sam will talk a little bit about that. Tam and I are going to sit down for a few minutes, and she and I will talk through a different aspect of this. So Sam's going from a technical side. Tam and I are going to talk from a people side, but kind of the landscape. What's the geography of this digital world that we're building? What does that look like, and how does it work? And so that'll be, I think, a cool conversation as well. We're going to hear from some of our community members who are building in this space. And that is another phenomenal and fantastic thing, because we can't do this if we don't have people building. We're going to hear from Jack Briggs for a few minutes as well. Jack's going to give us some updates on what's going on with Intersect. Thank you, Jack, for being here. And then I think a really cool pinnacle to the day, we're going to have Adam and Jenny, and they're going to lead a dRep debate. So we're going to take those first steps of what this self-governing structure is going to look like. What do these dReps do, and how do they answer the questions, and how do they differentiate, and how do they make their own way? So these are all questions. We don't have these answers. We've got to work toward these answers, and I think that the more we collaborate and work together, the better chance we have of answering these questions. So I think what I want to ask each of you to take away from today and to bring with you is where do you fit in? What is your shovel? What is your challenge? What is your particular brilliance that you bring to this community so that this community can grow? Because again, we're permissionless. We all have the right to be here. We all have the right to leave. No one can keep us here. No one can force us to be here. And no one can force us to leave. So because of that, each of us and each of our individual contributions are special. Because you choose this. You choose to be here. So think about it. Why do you choose to be here? What is that special thing that you're going to bring to Cardano in this coming year? What is your leadership role? So that's something that you'll see from me going more and more this year, is how do we build up leadership roles in Cardano? How do we empower more of our community members to take the roles of leadership so that it's not just our same faces? I love seeing these same faces. I know everyone in this room. I've spent time with every one of the people in this room, and I love that. But we can't be the only faces, right? We have to bring in more new faces. So how do we, in our particular area, bring in more new faces to Cardano? How do we offer leadership to others so that they come in and it's not daunting, it's not impossible, it's not
it'll be overwhelming, but maybe it's not too overwhelming. Maybe we can find a way to take that overwhelm down just a little bit so that they can build their own time in the community in their own way and maybe get to speed faster. Because now we've got the opportunity to have even more and more of these groups forming and even more and more of these groups talking and debating. Because like what we'll have today, when we have a dRep debate here on the stage, you're going to have individuals who have their own take. How long before those individuals represent a particular group of people who share their ideals? And then those ideals clash with others. It's bound to happen. We're humans. It's got to happen some way, someplace, that we're not going to be able to just all get along. We will have strong differences of opinion, but can we take those strong differences of opinion and make them professional, make them differences in policy and not differences in people, that we accept that we're all the humans in the room and that we all have the right to be here and we all choose to be here. I think it's going to be a truly exciting and interesting time, and I'm really looking forward to how we move this forward. So, and on that note, I think we're doing pretty good on time here. I'd like to give Sam Leathers his opportunity to come up here and tell us a little bit about what it means now that we're in the Conway era. So, Sam Leathers.
GM Cardano. So we're going to take a little trip down memory lane here. How many people in the audience here have been around since the Byron era? Who had a deadless wallet in Byron? We actually, that's almost half. Wow.
Eat my house.
So we're going to talk about the history of Cardano here and how we got to where we are. Because if we don't learn from our history, we're bound to repeat our mistakes. And that's what we want to avoid doing as we enter this world of governance. So, in the Byron era, we basically cobbled together a lot of technologies. RocksDB was one of them. Okay, so basically in the Byron era, we cobbled together a bunch of technologies. We took things off the shelf, RocksDB. We tried to get things up and going as soon as we could. And that basically, some of it predates me, but I got started pretty early on. I got involved in about early 2018. And at the time, I was just a DevOps engineer. I was basically supporting the nodes, deploying the nodes, talking to the exchanges when they had issues, and all those things that come along with it. So some things we messed up in the Byron era. RocksDB, how many people remember the data corruption issues we had on the Byron nodes, where basically you'd run a node and then all of a sudden it would have the wrong data in it and your wallet would have the wrong balances and you basically have to resync the node from scratch to be able to get everything correct. That was a huge problem that we kept trying to fix and just did not make a whole lot of progress on it. So what that led us to was looking at when we were getting ready to go to Shelley, which brought staking to everyone. We had to come up with a way, a new architecture that solved a lot of these problems that we had. So fast forward to 2019. This is when I really started getting involved with the tech of Cardano. This is when I started getting involved with the engineers. I went to the Berlin Delegation Summit, and we spent about 3 days, I think it was, going over the delegation specs, which was like 50-page documents, you can find them in the ledger, of how Shelley was going to work, how we were going to enact this research paper that the researchers had given us for Preos, and how we were going to do incentivization over it, and all these things. So we start working with that. We're looking at all these formal specs, and it's like, okay, we need to start developing it. Two teams basically were developing it. You had the Jormungandr team, and you had the Haskell team. And they started with very different ways of how they were going to get it done. The Jormungandr team was basically looking at how can we shrink the scope of this down as much as possible to be able to get something out as quick as possible to people. And that's what led to the ITM. We'll talk about that here in a bit. And the Haskell team basically took a different approach. What they said was, okay, where are our biggest problems in Byron Era? And two things basically came up. One was the storage layer, how we store blocks, what we do in case of data corruption, how we prevent inconsistencies and whatnot in the data storage layer. And the other thing was the network layer. So we're like, okay, how can we basically build a network layer that can perform at scale and be able to distribute nodes across the entire world and be able to come to consensus quickly. And that was the birth of what we call the mini protocols. We literally started with a ping pong protocol with this network layer. So we create these mini protocols. They're basically muxed together. And we start with basically sending ping packets, basically saying, ping, hey, I'm here, and then someone responds. And then simulating that over 1,000 nodes basically distributed across the world using a tool called IOSIM to make sure that things are working the way they are. And we slowly started adding in new protocols, like, for example, how to fetch a block header, how to fetch a block, things of that nature. Now, one of the things with the network layer that whenever you're dealing with networks in the real world that you really have to worry about is denial of service attacks. So when you're talking about a network layer, you want to make sure that permissionless nodes that talk to your node can't cause your node to go down because of too much traffic. So what we did with that was we split the network layer into two pieces. The one is basically the node-to-node protocol, and then you have the node-to-client protocol. And the node-to-client protocol is interesting because it only talks to a local node socket. So you literally have to take over that machine to be able to talk to it. So it's a very, very secure way to have these complex queries, like ledger state queries that dump the entire UTXO snapshot, or even like the debug queries that dump the entire ledger state entirely. We basically gated those behind this node socket, but then allowed these other protocols to basically fetch headers, fetch blocks on the node-to-node protocol. So we're basically building this stuff up block by block and figuring out how to do this. At the same time, the Haskell team had a significant larger task than the Rust team because they had to support the Byron Era. And how do we do that? So we have these nasty things called epoch boundary blocks that basically give us the leadership schedule at the beginning of every epoch, and they're huge, and basically list what every node is basically going to, when it's going to make a block in that epoch. Okay, and we have 20 seconds to generate that. Well, with Preos, we no longer have 20 seconds. We might have less than a second because you could have a height battle where I'm making a block, you're making a block in the next slot. So we had to be able to speed that up. And it's like, okay, how do we do that? So anyways, but we have to support all this stuff. So what we did was we simplified Byron itself to as small as we could and still validate the chain. So we just threw out tons of features that Ouroboros Classic had. And what we did an analysis for the consensus mechanism was we identified that we could simulate this using BFT rather than Ouroboros Classic and be able to meet all the requirements of being able to read the entire chain and have a new leadership schedule that basically just rotates between the 7 nodes from the 7 keys that ran the chain. And we did this basically by adding a protocol, a parameter into the configuration file that said the threshold of how many blocks, basically a percentage of how many blocks in the epoch could not be following the BFT leadership schedule. And we did some analysis, and I think we came up with 0.9 basically. So as long as 90% of the blocks included all 7 keys in them basically for the epoch, rotating around, it was fine. So we were able to simplify that. and get rid of Ouroboros Classic and have this PBFT. This is what we call the Byron reboot. This was the first hard fork on Cardano, where we went from Byron Classic to Byron reboot, and it was essentially a no-op. It removed a whole bunch of functionality that was not used anymore, or was never used to begin with. But basically, there was nothing new here. All you could do at this time is basically send money from one wallet to another wallet and receive money from one wallet to another wallet. You could buy some funds on exchanges and start playing around with it, but that was pretty much it. So then how do we get to that from there to Shelley? And Shelley, again, that's where we bring the stake pools in. That's where the whole community gets involved. So we have these node to client and node to node protocols going on the network side. We have everything set to be able to roll this out. What we don't have is necessarily a good way to roll out peer-to-peer to be able to find all these things. So we did a simplification there, and we basically created a central layer of nodes that was ran by the entities that allowed every person that had a stake pool to have an incoming connection from one of those nodes. So basically blocks would propagate, and then we encourage people to make your own connections, talk to your fellow SPOs, make sure that you have your own connections going. Call out to Marcus Guffler, who made the topology updater that basically let you auto-generate a topology for it. So we got the network layer solved. That's good. How do we actually fork into this thing? How do we get from one set of rules to another set of rules? Well, there's some precedent for that. And you see that with like Bitcoin forks. And essentially how it works is you switch from one code base to another code base, and you coordinate with a whole bunch of people to do this at a particular point in time. And then as long as everyone switches to that new code base at the right time, it gets enough stake, that becomes the authoritative chain and it goes forward. I mean, we could do that. How painful is that, though? Can we do something better? Out of this comes the hard fork combinator. And this was Edsco from Well Typed that came up with this idea, where you could have a list of rules of what you're currently operating, and you have another list of rules that you want to get to. And basically, you have this two security window range, basically, that you know you're going to be switching the rules. So then at the end of the epoch, once you decide you're switching the rules, it just flips it. And you can change the rules in any way you want. You can completely change the entire rules of the game every hard fork. Now, you obviously don't want to fully do that, because if you do that, then you start breaking people's functionality. But the technology is there to be able to do upgraded systems. And you'll see as I talk further how useful this is going forward. So then you have the whole wallet problem. So with Byron wallets, who had a Daedalus wallet? Everyone remember the DDZ addresses you got from your Daedalus wallet? These were, we called them random addresses. And that's because we used a random number generator based on your seed to generate an address. And then that address had some metadata associated with it that told you something about the account pub key that was associated with your wallet. And you collected all these addresses. So, I mean, some exchanges had like some 300,000 addresses in these wallets. They have to track each one of these, and they have to basically, every single address that comes on chain, they have to check, does that have that metadata associated with my account? And if it does, then basically I have to figure out how to generate that so I can get the key to be able to handle it. And huge performance nightmares with this. Huge performance nightmares. You have a giant wallet, it becomes a mess. So the wallet team basically went and they were like, okay, how can we do this better? So a thing called Icarus. Who remembers Icarus? Anybody? Project Icarus? Okay, so Project Icarus was this idea that, well, we don't really need to do this random generation. We can just start an index and increment it every time. So we did this with the Byron addresses, and if I remember right, it was AE2 they began with on the first three characters, basically the wallets. You could identify what kind of address generation scheme you were using by the prefix, basically. But you have these, and Emergo basically was like, well, we want to run with this. We want to build a wallet that uses these Icarus addresses. And Yoroi was born. And how many people used Yoroi after Yoroi was born instead of Daedalus? Yeah, there's a number of you here. Why not both? Exactly. So the downside of Yoroi was you trusted a central entity. It was a light wallet. You did not control your own node, whereas Daedalus itself, you had complete control of the node. There was no central entity you had to use. Okay, so that's Icarus. So then we take this Icarus idea and we apply it to the Shelley era. We never applied it to Daedalus in the Byron era. But the Shelley era, it's like, okay, we're going to improve on this, and this is where we're going to go with it. Okay, so we have this idea of basically you can generate, you have a gap of how many the chain will look for. So you don't have to look for every address. You only have to look for the next 20 and the ones that you've tracked so far. So that's basically the wallet going into Shelley. I'll talk a little bit more about that here. So yeah, that basically covers, I think, most of the problems we had with the Byron era. So let's actually talk about the Rust side a little bit, how we did Jormungandr. So we get something up rather quickly. We have what was called the local node. Who participated in the local node leading up to the ITN? Anyone? Okay, so the local node was basically a simulated node that you could run locally and pretend that you had these different stake pools making blocks. And there wasn't a network layer yet, so people were messing with that. They were trying it out. Everything was going pretty good. Then they had the network layer in. The network layer, they used off-the-shelf gossip protocols they could find in Rust. I don't remember the name of the protocol it was that they were using, but basically gossiped around and found peers and connected those peers, and then basically that's how the connections happened between them. Okay, so now we have this network layer added to it, and people started testing with that, and we start noticing that we're having a little bit of divergence in the thing. So tweaking parameters, we think we have it down. There's probably participants, I don't know, somewhere in the range of like 10 to 15 or so that were originally participating in the early network experiments of pools. It wasn't a huge amount, and everything was going pretty good. People come up with this idea of, okay, how do we incentivize more people to come? And this idea of the ITN was born. We can basically pay people to test this out. We pretend we're in the Shelley era before we're in the Shelley era, track all those rewards, and then apply them to mainnet. That was the general idea of what the ITN was supposed to do. So we do that, and we have an explosion of people. I mean, I think we had some like 200-300 stake pools running in the ITN. So gossiping's happening. Nodes are trying to find each other. What happens? Giant forks. Like giant forks, multi-day forks where the node basically is talking, everything's good, and then it rolls back and deletes like thousands of blocks. And it's like, I made all those blocks and now I'm not getting rewards for it and whatnot. So this happens. This is, of course, it launched right before Christmas. So I'm leading the SRE team. We're literally being pulled in on Christmas Day to reset nodes and get them going. And yeah, so basically what we ended up doing after Christmas was we were like, okay, we need to have some sort of central authority and whatnot.
So how we achieved that was we basically told people, you got to restart your nodes like multiple times a day here. Otherwise, we're going to have these forks and you're just going to lose all your blocks. So every time it restarted the nodes, it only talked to the central ones that my team was running. So it would get on the right fork and then it would make some blocks, and some of those would basically get lost as it started connecting to other nodes. But if you restarted your node, you only lost a few blocks, and then you could hope that basically you got some more coming. So we did that. This thing's running for like 6 months. I have so many stories of people talking to me, and it's like, oh yeah, I was up like 24 hours basically, many days just trying to keep my node to get blocks on the ITN and trying to be the most competitive, and basically me and one guy basically switched back and forth 12-hour shifts, and anytime that we saw we were getting on a fork that was separating from the main IOG nodes, we'd instantly restart our service. People started writing scripts to do it. They basically would monitor like their tip compared to the IOG nodes, and they'd just like force restart their node every time they diverted like more than 2 or 3 blocks. So it was a complete crazy time. And then we start introducing Shelley on the Haskell side. And Shelley on the Haskell side was completely different. We had the friends and family. Who was anyone part of the friends and family here? Okay, so we started with the friends and family testnet. We reached out to some SPOs that were very well known on the ITN, people that were helping other people significantly on the ITN, people that were creating this community of SPOs. And we get them involved, and they start using it, and we don't have the hard fork combinator yet. So we're basically just launching a testnet in Shelley that's following the formal method spec, and everyone's basically participating on this. And I would literally get comments on Telegram at the time because we weren't using Discord yet. I'd literally get comments every day. It's like, there's got to be something wrong here, because like I'm not getting any alerts, and how can I make sure that like my thing's actually working correctly? And because it was so strong and so formidable, because it was built from those ground principles of how do we connect the network, how do we make this performant. And another part of the performance piece, I got to credit Serge Kosarev, who was originally also a DevOps guy, that he decided he wanted to be part of and lead a benchmarking team in 2019. So he basically comes up with this idea of how do we benchmark this so we know exactly, looking at forge metrics, how long it takes for this one block to propagate all the way across the world in this simulated environment with 50 nodes. And we start doing these benchmarks, and every single release that we've done since that time, and we've added more metrics we're looking at, our reports have more data in them, but every single release we compare to the previous release, look at the benchmark results, and if it doesn't pass, it does not go forward. And this has been a frustration with lots of people, I'm sure, because this is what, when people talk about delays on the Cardano node, this is what happens. There's some sort of regression that happens. There's some feature that slows things down so much that basically the technical team cannot sign off on that release, and we have to fix it before we get it out there. Okay. So we got that going. We have the friends and family testnet. Everyone's much happier on the friends and family testnet. And now it's time to figure out how to actually migrate all this Byron stuff in. We have the hard fork combinator, so we're going to test it out and everything. What's the governance layer going to look here? And this is where governance comes in. What is our governance layer? How do we actually decide when we go from one era to another era? What protocol parameters can we change without changing eras? All these things. And basically what we did was we built an entire governance layer, assuming that in the future, anyone would be able to do this. But initially, just like we did with the stake pools where we slowly rolled it out, we basically said we're going to take the central entities and they're going to govern the chain for now. and then we'll be able to hand it off at a later date. But we're going to build this in a way that we're doing these transactions on chain to basically submit a proposal to do this thing, and you have to get consensus among these nodes all agreeing that, well, these nodes keys, the delegate keys, all agreeing that we're going to go forward. So we have a governance layer. We have the hard fork combinator. We have the Preos stuff implemented. We've benchmarked it. We're ready to go. We launch. Anyone remember the disaster that happened after we launched? Anybody? There wasn't one. It went off without a hitch. And we also had native scripts already. A lot of people don't know that. That basically, when we launched Shelley, you could already create a multi-sig wallet, and you could basically have multi-signers sign off of it. Okay, so we're going to accelerate through this a little bit quicker here because it's just not very interesting because we already have the hard fork combinator. We're just adding a few features here and there. So next era, Allegra. Anyone know what Allegra was? Time locking. Time locking. So we updated the native script standard to have time locking, where you can basically say that this thing can only be spent in this particular time range, or it cannot be spent in this particular time range. The general idea with this was for Project Catalyst. The general idea for Project Catalyst initially was that everyone would basically lock their funds up. There'd be a snapshot taken, and then it would be locked during the voting round, and then you'd be able to access your funds afterwards. We didn't go forward with that, actually. We came up with a better design for it. But that was the onus for getting time locking going. But the way we developed the era for Allegra, we were able to flip it around rather quickly. It was about like 2 or 3 months, and we introduced Mary. And Mary was a stopgap measure the devs came up with because everyone wanted smart contracts. Everyone was like, when smart contracts, when smart contracts, when smart contracts. Well, what can we deliver? Because Plutus wasn't ready yet at this time. What could we deliver without smart contracts? And it was like, well, I mean, we could basically take this native token standard that we're going to use with the smart contracts, and maybe we can launch that now with native scripts for minting and burning. And we're like, okay, let's try it. So we rolled it out. We figured maybe just like multi-sig, maybe like a handful of people would test it, try it out, see how things work. Anyone know what happened after that? NFTs galore, native assets galore. Cardano is probably most known for how many different tokens are on it because it costs 200,000 Lovelace, not even a single ADA, to mint millions of tokens. So now we have native tokens. People are actually using the chain. They're building tools without smart contracts to exchange these things. They're building these cool JPEG standards to throw into assets. So basically you can have this beautiful picture associated with this asset that only you have. Okay, so Cardano's for real now. So what's next? We finally get smart contracts. That's coming up just shortly after. I want to say it was, it was 2021 when we got native assets. I think it was toward the end of that year, I think, when we got smart contracts for the first time. Yeah, so about 6 months later, we have a new era, and we've launched smart contracts on the chain. Now we have Goguen and whatnot. Smart contracts was a very blind spot for us. We didn't know how people were going to use them. We didn't have enough people educated on basically the difference between UTXOs and account models. And it was a little bit of a rough start for us. I mean, we had a Sunday launch fairly early. All of a sudden, our chain was like completely loaded, and we had to figure out how we could quickly optimize it within the code base itself. And we adapted fairly quickly, and like within a couple months of the Sunday launch, we actually had things fairly stable for a good while going there. But we needed to improve it further. So we started looking at, okay, so you got to throw your entire script basically into the transaction. What else can we do? So reference scripts. We started adding new primitives and whatnot. We added the SecP stuff and all that stuff. And that was basically the Babbage era. And there were two parts of the Babbage era. There wasn't supposed to be, but we ran into a last minute correctness issue with the SecP stuff that we basically had to create a new hard fork for it. And we had, with the hard fork combinator, you can have new eras, and you can also have what's called intra-era hard forks, where you add small functionality or turn on limited functionality at a particular point in time that's already developed for that era, but just not available yet. And that's what we did to enable the SecP. So it was about 7-8 months after the launch of Babbage or so, we had the SecP stuff activated. And some of that was basically what I went back to before, benchmarking. So we started doing some optimizations and whatnot, and things slowed down. So we had to make adjustments to be able to get that out. And we got everything going and we rolled it out. It took a long time for people to upgrade. Long time. I mean, I think we were looking at like 3 to 4 months basically from the time we had the release out to the time where we had enough exchanges and block producers updated and whatnot. So we're moving along, and it's like, okay, what's our next thing going to be? And everyone's thinking scalability. We got to make this scalable. It's time to start looking at this Laos paper that just came out. Let's do scalability. And Charles actually had a rather controversial idea at the time, and it was like, we could do scalability now, but how long are we going to keep pushing down governance down the line? How long are we going to continue basically making all the rules and not letting the community participate in it? So he was like, okay, let's figure out how we can do this. And he invited me and Kevin and Jared, if you remember Jared, and a few other people to Longmont. And we basically were whiteboarding for like 3 days. And the first one was like beautiful. We were like, oh, we're going to do this full voting system. We're going to use mithril snapshots to basically take it off. And we're going to use Hydra to build this entire voting platform and everything. And we're going to be able to do all the voting there. And then we're going to have a smart contract at the end that basically takes everything off of Hydra and brings it on chain. And it was like, well, how long is this going to take? And we're like, well, let's talk to the Mithril and Hydra team. And they're like, probably 3 to 5 years or so. And it's like, okay, can we do anything quicker? Is there anything we can do to bring governance to the people now? And Jared, me, and Kevin are whiteboarding. And it's like, well, I got an idea. Let's add a voting key to the address. So we're like, okay, let's add a voting key to the address. So now we can do everything native in the ledger. And it's like, okay, so what's this going to cost us? Well, memory is going to go up about 33% because all the addresses are going to be longer and the UTXO set's going to be larger. That's going to be a bit of a pain. Everyone's going to have to move all their money. They're not going to be able to just take their wallet. They're going to actually have to move all their funds from just a staking address to a voting address. That's going to be a pain for like a lot of people here. Are people actually going to do it? And so then we're like, how else could we do this? And we're like, we have a design for this already. And it's like, what's that design? Stake delegation. You have a stake address, you delegate to a pool. What if you could delegate to a voting address? So we're like, oh, that's a great idea. Everyone generates their own voting address, and now everyone can vote on chain. And then, so we're going down the road on that. And it's like, okay, scalability wise, can we do that? Can we have everyone vote on chain? Is everyone going to participate? Is everyone here going to vote on every action? What if we have 20 actions on chain? What if people don't feel like they have the expertise to be able to vote on it? And we're like, well, it's just an independent generated key. What if we create a new governance class and we called it, I don't know, a delegate representative or something? What could we call it? A dRep. Okay, so we got a dRep here, so people can register to be a dRep. What's that going to look like? Well, we already designed that. We have stake pools. It's a registration certificate, and you basically make a declaration that I'm going to be a stake pool. So we'll just do the same thing and make a dRep. So we're talking about it and everything, and it's like, okay, so how often are we going to have these elections for dReps? What's this election process going to look like? And we start talking about it, and we start talking about separation of powers, and that we need to have some sort of Supreme Court and everything associated with it. And Charles stands up and he's like, let's do something no one's ever done before in the history of governance. What, Charles? Let's do liquid delegation. So now anyone can change who they're delegating to at any time without having to wait for a special election. At any time, they can basically just go and say, you know what? I want to delegate to Jenny today. I want to delegate to Adam. I'm using their names because they're not dReps, because I don't want to give any people ideas on who to delegate to. So now we have this beautiful governance layer. We have these dReps, and it's like, okay, so what else do we need to form this government? And we're like, well, we need some sort of constitution, I think. I don't know what that looks like. I have no idea, but we need to have some sort of rules everyone agrees on, some sort of vision of what we believe. And it's like, okay, who enforces that? Well, I guess we need some sort of committee for that. Okay, what's that committee going to look like? How are we going to handle that? When is that committee elected and whatnot? So we were like, well, we have this dRep thing already. We already have these keys for dReps. Couldn't we do the same kind of liquid thing for a constitution committee? But do people delegate to it? No, we don't really want to have them delegate to it. Well, what if we just have an action on chain that the dReps vote on? And it's like, well, what if there's some coercion and if you only have dReps voting on it? Is there a check and balance here? Because the Constitution Committee isn't going to be able to vote on this because that's kind of outside of their interests. And it's like, we have another governance class already. Oh, what is it? Stake pool operators. We can utilize them for the things where we absolutely need to have another body of government to be able to come to consensus without being able to trust the CC to do it. So we bring the stake pool operators in, and they're able to, we decide that, maybe they should be voting on some security parameters that they're going to be experts in. They're obviously not going to be voting on the economic parameters that they can manipulate and whatnot for their own gain. But there are some network parameters and whatnot we might want to have them involved in for the voting. So we pick those out. We figure that all out. We have the Constitution Committee. We just do an update Constitution Committee action. And we set it up so you can have a min committee size, and then that can be changed through the governance process itself. The system actually runs, and it initially ran when we first launched it with a Constitution Committee that was empty. So it works without it. If you want to get rid of the Constitution Committee, you can basically just make it an empty set and set min committee size to 0. And now you don't have a constitution committee anymore. We have a constitution. We have full governance. Okay, how long is it going to take to do this? I don't know. Maybe a couple years. Can we do it any quicker? And it's like, well, let's see. Is there any way we can iterate on this faster? What can we do in the meantime? And how do we get this ratified? Like, how do we get people to agree to this? I mean, we can't just tell them that this is what we're going to do. We got to have some sort of mechanism for it. So we start writing the SIP process, go through the SIP process. We write the SIP up, have it written up in about a month for the first draft, get some reviews, talk to some community members about it, and then we finally publish it. I think that SIP ended up with like hundreds of comments of people saying, I don't like this, I do like this, we should change this, that, everything. Okay, how do we manage the governance to be able to figure out what the SIP is going to look like? And Charles again comes up and he's like, why don't we just bring them all to Longmont? And it's like, okay, that sounds like a good idea. So we start picking people in the community that we know really care about this stuff, invite them all to Longmont, and basically talk through what SIP 1694 is, get ideas from them of what they think of it, how they would change it. At that meeting, basically, the whole idea of locking stake actually came up. That was not talked about at all until that day when people were there. So we're having that conversation in real time with people. And it's like, okay, we did it. We got consent and everything. And Charles is like, that's not enough. And we're like, what do you mean that's not enough? We figured this all out. We're ready to start developing it. Let's go. And he's like, it's not enough. There's only so many people here. We need everybody to talk about this. And it's like, okay, how do we do that? So we start having these workshops, and we had 50, I think, in entirety, some of them virtual, some of them physical. And we wrap it all up about 4 months later in Edinburgh with a final one to go over all those results and talk about it. We invite a lot of controversial people that we know we're going to poke holes in it. People like Kenrick, people like Johnny Kelly, and whatnot. And we just all debate this stuff and we figure it all out. And at the same time, the team's been developing 6 months as hard as they can, figuring out what this era is going to look like. How can we do a minimal voting model? And we do a demo of this new voting model. And we basically say, okay, we haven't built the dReps yet. Let's just use the SPOs. So we show a vote basically using the SPOs. And the first constitution we showed the first action we showed in the demo was a new constitution, because we felt that the constitution was so central to what we were doing. We wanted to show that that was basically the first thing that we could demonstrate using this voting model. And then we had the meeting with Charles, and it's like, okay, how do we get the rest of it? And we built the roadmap up and figured out the next 6 months of work, figured out how all that was going to work. We were like, okay, we can do this fast. We absolutely can do this fast to show progress and to get people involved. But there's going to be some time on the tail that we need to worry about to basically solve those nasty performance issues that prevent you from getting releases out. There's going to be some last minute tweaks we're probably going to have to do. And we're going to have to figure out the cost model for how this is going to work, because of course we're going to have smart contracts in it. And we're going to introduce this thing called a guardrails script and whatnot in it that we're not going to have time to do in this short period of time that we're rushing this out. So we do that. We have about 6 months of polish and everything. We get it out. Constitution Committee, the three entities have their last final vote on chain to basically hand this off to the Constitution Committee. At the same time, we figure out who's going to be part of it. We bring in members. We have votes basically to get three. We take the founding entities, and then we have another seat for Intersect and whatnot on it. And that's our governance system. That's where we're at now. And yesterday, it passed. We're going to full dRep governance next week. So, like I said, I wanted to start this whole thing out talking about the mistakes we made along the way. And I wanted to talk about the community interactions we had, because that's been a key part of Cardano throughout. All the way from the ITN till now, we have been working with the community and trying to solve these issues. And now it's up to you guys. Where do we go from here? And the product committee is putting together a vision and roadmap. We're working with product people from IOG. We're working with lots of people in the community. Some of them were elected. I was one of the most recently elected ones. And we're taking feedback. We're talking to people. If you have any ideas on what you think should be in the core roadmap for Cardano for 2025, come reach out to me. But we're going beyond that. So we're going to get this 2025 vision roadmap out soon, hopefully. But beyond that, we're going to form a 2030 vision for Cardano, because it's up to us now to figure out what our actual vision is. And it might be very similar to what we have now. We might have broad disagreements about what the vision is, but we're going to figure that out together as a community. And I invite all of you to participate in that process. We're going to do a similar thing to how we did SIP 1694. And we're going to have this workshop model. A lot of it's going to be virtual. We're going to try to do everything through GitHub, open source. So basically, each workshop is basically going to be submitting changes to whatever that vision is as it goes, the initial vision, how it started and whatnot, all that's still kind of being figured out. But yeah, I invite everyone to participate in that process, because Cardano really is about you guys, the community. Sure, me and the developers here are making sure we don't shoot ourselves in the foot, and we're making sure that the benchmarks pass, and we're making sure that we have proper formal methods, that we're not going to break things along the way. But what we do, what we develop next, where we put our focus, is up to everybody here in the audience, everybody watching abroad, and everyone that watches this recording a year from now. So I mean, it's going to be a liquid system. We're going to adapt quickly. We're going to work with people. We are going to basically come together as a community and figure out what this all is. And it's going to be messy. Governance is messy. Governance is hard. But that's what makes it fun. That's what makes it so important to be part of this community. So I invite everyone here. If you want, talk to me later. I'm happy to talk with people more about this in detail. But get involved. Get involved in Intersect. Get involved in building the Cardano roadmap. Get involved in building the new things for Cardano. And support your local community members that are doing it. Thank you very much, folks.